Hello friends, I welcome you in lecture number 6 on sampling distributions. In lecture number 5, we have discussed about sampling distribution of sample proportion. So we just discuss what we have seen in lecture number 5. Suppose we are given some population with some characteristic, and it is given that population proportion for that characteristic is some constant, and suppose we are given the sample of size n in which capital X is the number of observations which are having that particular characteristic, then we know that sample proportion is given by p hat equal to capital X divided by n. And we have seen in previous lecture that if these two conditions are satisfied, n times p is greater than 5 and n times 1 minus p is greater than 5, then this capital X is a normal random variable, and therefore we can say that capital X minus mean of capital X divided by standard deviation of capital X is a standard normal random variable. Now what is mean of random variable capital X? So mean is n into p for this variable X. And what is standard deviation? Standard deviation is square root of n times p into 1 minus p. We are familiar with these two formulas, mean and standard deviation of a binomial random variable. Mean is equal to number of trials into probability of success. Variance is n into probability of success into 1 minus probability of success. So this we have discussed in earlier lecture. Under these two conditions, we can say that this capital Z is given by this, and it is a standard normal random variable. Now suppose we divide numerator and denominator by n, then here I have x divided by n minus p. I am dividing this quantity by number of elements in this sample. Similarly, here I am dividing by n, so that means I can write in this way, square root of n square. So that will give me p times 1 minus p divided by n. Now what is this capital X by n? It is sample proportion. So we can write capital X by n equal to p hat minus population proportion divided by p times 1 minus p divided by n. So we are writing equivalent form for this by dividing numerator and denominator by n, and we find that Z equal to sample proportion minus population proportion divided by this quantity. So this is also a standard normal random variable. That also we have discussed. We have discussed in previous lecture that the mean of sample proportion is given by population proportion, and standard deviation of sample proportion is given by square root of p times 1 minus p divided by n, and therefore Z equal to p hat minus mean, that is small p, divided by standard deviation, which is p times 1 minus p divided by n. This is approximately a standard normal random variable, and if you forget, you can derive in this way also. So this is mean of sampling distribution of sample proportion, and this quantity is standard deviation of sampling distribution of sample proportion. So we will keep this in mind, and this is true for large samples, and for that we will remember this condition. Some sources consider instead of 5, some sources consider 10, and some sources consider 15 also, but all are reasonable conditions which we can use. We will follow this 5 for this requirement for normal distribution. So all you have to remember is that suppose we are having some population, and we are interested in some characteristic of that population, and the fraction of the population is given which is following that characteristic, that we will call as population proportion. Suppose we are drawing a sample of size n from that population, and capital X is the number of elements or observations or individuals in that sample having that characteristic. Then we can talk about sample proportion, which is given by capital X divided by n, and the sampling distribution of sample proportion has mean equal to population proportion and standard deviation equal to square root of p times 1 minus p divided by n. And under these two conditions, n into p is greater than 5 and n into 1 minus p is greater than 5, we can say that z equal to sample proportion minus its mean, that is small p, divided by its standard deviation p into 1 minus p divided by n is approximately a standard normal random variable. So keep in mind this thing, and using this we can answer this, we can solve this problem. Suppose that 43% of Americans own an iPhone. So here the population is of all the Americans. Our population is the set of all Americans, and characteristic is having or owning an iPhone, and it is given that the proportion of iPhone in the population is 0.43. From that population they are taking a random sample of 50 Americans for survey, and we have to find the probability that the proportion of the sample, that is sample proportion, who owned an iPhone is between 45% and 50%. So if we denote sample proportion by p hat, then we have to find the probability that the proportion of this sample, that is p hat, is between 45%, that is 0.45, and 50%, that is 0.50, that we have to find out. Okay, fine. So here we first write down that we are given that population proportion is 0.43 and the sample size is 50. They are considering a sample of 50 Americans. Value of X is not given, but that is not a problem for finding this probability. So we know that if we consider the characteristic of owning an iPhone, then if we consider capital X equal to number of Americans, the number of Americans which are owning an iPhone, if we consider this capital X equal to this number, then it is clear that capital X is a binomial random variable. For each American there are only two possibilities: either he owns an iPhone or he or she does not own an iPhone. and we are considering sample size equal to 50, that is finite, and we can assume that all the 50 persons are independent, and probability of having an iPhone is 0.43 and it is constant for each person. So we can say that this capital X satisfies the conditions of binomial distribution. Now we have to check whether we can apply normal approximation to that binomial distribution or not. So for that we have to calculate these two numbers, n times p and n times 1 minus p. If these two are greater than 5, then we can say that z equal to p hat minus small p divided by square root of p times 1 minus p over n. This is approximately a standard normal random variable. So using the cumulative probability table of standard normal random variable, we can decide this probability. We will convert this probability into standard normal random variable. Once we know that this random variable is a standard normal random variable, we will convert this probability into standard normal probability. For that, what we will do, we will convert this into standard normal random variable. Here we write mean of sample proportion divided by standard deviation of sample proportion. This is less than p hat minus mean of sample proportion divided by standard deviation of sample proportion less than 0.50 minus mean of sample proportion divided by standard deviation of sample proportion. And we will substitute mean of sample proportion equal to small p, and standard deviation is given by square root of p times 1 minus p over n, and we are given values of small p and n is 50, and using this we will see that this is nothing but standard normal random variable and all these quantities are constant, and using standard normal table we are able to decide this probability. So I have written all these things systematically here. Given that population proportion is 0.43, it is given that 43% of Americans owned an iPhone. Therefore population proportion is 0.43, and they are considering a survey of 50 Americans. Therefore sample size is 50. Now n times p, that is 50 times 0.43, which is 21.5, it is greater than 5, and n times 1 minus p is 50 times 1 minus p, that is 0.43, and this is also greater than 5. Therefore the sampling distribution of sample proportion p hat is approximately normal, with its mean equal to population proportion, which is 0.43, and variance equal to p times 1 minus p divided by n. P is 0.43, 1 minus p is 0.57 divided by n, which is 50, and this turns out to be 0.0049. Therefore standard deviation is square root of this variance of sample proportion, that turns out to be 0.07. And now we are interested in this probability that sample proportion lies between these two numbers, 0.45 and 0.5. So as I discussed, we know that if these two conditions are satisfied, n times p is greater than 5, n times 1 minus p is greater than 5, then sampling distribution of sample proportion is approximately normal, and now we standardize it. We know that p hat is a normal random variable, and therefore we standardize p hat by subtracting its mean and by dividing by its standard deviation. So this I have written equivalently 0.45 minus mean of sample proportion divided by standard deviation of sample proportion less than this sample proportion minus its mean divided by standard deviation less than 0.5 minus sample mean of sample proportion divided by standard deviation of sample proportion. And now we are having these two values. Mean is 0.43, standard deviation is 0.07, that we substitute here, here and here, and this is standard normal random variable denoted by capital Z. This quantity turns out to be 0.2857. This becomes 1. And using the properties of standard normal table, this I can write as probability that Z is less than 1 minus probability that Z is less than 0.2857. Okay, it is like this. Suppose we have 0 somewhere here, here we have 0.2857, and suppose I have 1 here. So to decide this probability, first I am considering probability up to Z equal to 1, that is probability that Z is less than 1, and I don't require this part. So I am subtracting this probability that Z is less than 0.2857, and these two probabilities are cumulative standard normal probabilities, so that we can decide using cumulative probability table for normal distribution. This we have to round off up to 2 decimal places. If I round off up to 3 decimal places, then here I have 0.286, and for 2 decimal places it is 0.29. So first I write this by rounding it up to 2 decimal places. Now for this I have to see in the cumulative standard normal probability table. So let me find out that table, statistical tables, and I have to search for cumulative probability table. Just a minute. So we are interested in probability that Z is less than 1, and the probability that here we are given cumulative standard normal distribution table. So first we find out probability that Z is less than 1, and that I can write as probability that Z is less than 1.00. So in the table we are given all those cumulative probabilities. This is the probability that capital Z is less than small z. So I have to search in this left column, I have to search for 1, and here I have to consider 0.00 because my Z value is 1.00. So in this column I have to go up to 1. So this is 1, and I am interested in this Z value 1.00. So this is 1.0 and plus 0.0. So at the intersection I find out 0.8413. Probability that Z is less than 1.00 is 0.8413. Another probability we are interested is probability that Z is less than 0.29. That is small z value is 0.29. This I can write as 0.0 plus 0.2 plus 0.09. I have to write in this way, because you can see here I have 0.01, 0.02 up to 0.09. So 0.29 is written as addition of 0.2 and 0.09. Therefore in this left column I have to go up to 0.2, and here I have to search for 0.09, that is last column, and this is for 0.2, this row for 0.2, and here I am going up to 0.09, that is 0.6149. Probability that capital Z is less than 0.29 is nothing but 0.6141. So now we can substitute these two values. Probability that Z less than 1 is 0.8413, and this probability that Z is less than 0.29 is 0.6141. So that I have substituted here. Probability that Z is less than 1 is 0.8413, and this is 0.6141. So here we have to write using standard normal cumulative probability table, and the difference is 0.2272. So therefore the probability that sample proportion lies between 0.45 and 0.5, or the probability that the probability that iPhone owners are in between 45% and 50% is 0.2272. So that is what we required to answer in this example. What is the probability that the proportion of the sample who owned an iPhone is between 45% and 50%? And using this sampling distribution of sample proportion, we are able to answer this question. To answer this question, you must be familiar with the sampling distribution of sample proportion. That is, you must be familiar with this formula. We must be familiar that this Z is a standard normal random variable if these two conditions are satisfied, where p hat is sample proportion, small p is population proportion, and small n is number of observations in the total number of observations in the sample. So in this lecture we have discussed the application of the formulas of mean and standard deviation of sampling distribution of sample proportion. So I hope you like this. Thanks for watching.